So yesterday we just started with the thermal properties of matter beta, thermometer and thermal expansion of solids. We have done the sum of the formulas related to them. Let us try to fastly do some problems beta. See the problem number 1. Everyone beta, make it fast. At what temperature does the temperature in the Celsius and Fahrenheit will equalize beta? At what temperature does the temperature in the Celsius and Fahrenheit will equalize? Standard question. You might have been done this one so many number of your times. Should give me the answer fastly. Nandini. At what temperature does the temperature in the Celsius and Fahrenheit scale will equalize? Celsius is equals to Fahrenheit at what temperature is asking? Option A, very good. Isn't it? What is the relation between them beta? F is equals to 9 by 5 into C plus of your 32. Isn't it? That means F is equals to C. So C is equals to, this I can write as of your 9C plus of your, this will be equal to your, how much for me? 5. So 5 into your 32. This will become how much for me beta? 5 into 32. 9C divided by 5 plus of your 32. That means this will become for me 160 divided by your 5. 5 3 is 15. 5 2 is 7. So this will be equal to your 5C is equals to your 9C plus of your 160. All the C terms on you take on one side. So this will become for me C is equals to your, this will become for me minus 40. 4 6 are, isn't it? So that will be answer minus 40 degrees centigrade. Got it everyone? Done beta? Chalo, next question. A difference of the temperature of 25 degrees centigrade is equivalent to the difference of how much? 45 degree Fahrenheit, 72 degree Fahrenheit, 32 degree Fahrenheit, 25 degree Fahrenheit. Difference of temperature of 25 degrees centigrade. Difference of temperature. That means some temperature difference C1 minus of your T2 will be equal to how much for me? 25 degrees centigrade. It is in the Celsius property. You know the relation for the Celsius beta? C is equals to your 5 by 9 times of your F minus of your 32. So C1 will be equal to how much beta? C1 is equals to 5 by 9 into your F1 minus of your 32. The same way C2 is equals to 5 by 9 into your F2 minus of your 32. Is given the answer in terms of your Fahrenheit. That is the reason I'm writing there. So C1 minus of this C2 will be equal to 5 by 9 common into this will become for me F1 minus of your F2. This will get cancelled anyhow for me. So C1 minus C2 is equal to how much for me? 25 is equals to 5 by 9 into your F1 minus of your F2. See how much I'm getting better there? Option A, very good. So this will become for me 25 into 9 divided by 5 is equals to your F1 minus of your F2 difference. 5 anza.
40, sir.
How much better? 40 it is
45, sir.
45. 5 5 is 25, 5 9 is 45, 45 degrees. So F1 minus of your F2 will be equal to your 45 degrees. Clear? Chalo, next one. Which of the curves in the figure represent the relationship between the Celsius and as well as of your Fahrenheit scale? Make it fast better. Anyone? Which of the curves in the figure represent the relationship between the Celsius scale and Fahrenheit scale? A, this one is B, this one is C, and this one is D. So these are the graphs better. This one are your X and Y graph basically. Spotlight. Okay. But tell me, what will be the answer? Which of the curves in the figure represents the relationship between the Celsius and the foreign heat temperature? Write the relation between Celsius and foreign heat better. You will get the answer. C is equals to how much for me? 5 by 9 into your F minus of your 32. Isn't it? That means C is equals to your 5 times of your F divided by 9 minus of your, this will become for me 160 divided by 9. So if I'm comparing with a straight line equation, y is equals to m into your x minus of slope. That means constant should be negative. C is equals to minus of 160 divided by 9 and slope m is equals to your positive, and that value of that one is 5 by 9. Slope will be positive means it should be, slope must be lesser than of your 90 degrees. Lesser than of your 90 degrees, and C should be constant. So C should be negative first. So first try to identify the curve which is having C negatives. So this one is C beta on x-axis, this one is C negative. Okay, this graph is there, this graph is there. But for this graph, if I'm taking angle, this angle is theta greater than 90 degrees. For this one, this angle is theta is lesser than 90 degrees. So A will be the graph. So curve A will be the answer. C is not possible because for this angle, theta is greater than 90 degrees. Slope 90 degrees is not greater than possible. And even for this one, slope is positive. This slope is positive. So obviously B is also not possible. D is also not possible. Only option A. A will be the answer. Nandini Achinda. Is it clear? So what is the slope I'm getting beta? Slope value is equals to 5 by 9. In between the Celsius and foreign heat, the slope value is equals to 5 by 9. Slope means what beta? Tan theta only, na? Slope is nothing but what? Tan theta only. Tan theta value is equals to 5 by 9. You may also ask what is a theta. So theta will be equal to your tan inverse of your 5 by 9. Clear? Chalo, very good. Next question. The graph AB shown in the figure is a plot of the temperature of the body in the degree Celsius and degree Fahrenheit. Then what is the slope? Abhi kare hum log ne. So C is equals to your 5 by 9 times of your F minus of your 32. So that means this one is 5F divided by 9 minus of 160 divided by 9. So slope will be equal to 5 by 9 beta. Slope of this line AB will be equal to your 5 by 9. Clear? Chalo, very good. Next one. Oxygen boils at minus 183 degrees centigrade. This temperature is approximately in Fahrenheit. You should tell me the answer for this one. How many of you can give the answer first? बरका बोलो बेटा. Thermal property चल रहा है शायद ना अभी आपको?
क्या बोले सर?
Thermal property चल रहा है शायद ना अभी?
नहीं सर, अभी नहीं कर रहे थर्मल प्रॉपर्टी.
क्या चल रहा है अभी?
अभी सर एक में ऑसिलेशन और एक में ग्रेविटेशन.
अच्छा, okay. Oxygen boils at minus 183 degrees centigrade. This temperature is approximately in the Fahrenheit. Fahrenheit और इसका temperature का relation बताओ बेटा. C minus 0 divided by 100 minus 0 is equals to your F minus of your, यहाँ पर कितना हो जाएगा 32 divided by lower temperature is 212 minus of your 32. यही तो relation है, isn't it? So this one will be equal to how much for me? Celsius पे temperature कितना है? Minus of 183 minus 0 divided by 100 minus 0 is equals to your F minus of 32 divided by 160. बताओ कितना आ रहा है जल्दी से? Minus 183 divided by your 10 is equals to F minus 32 divided by 16. ये 0 और ये 0 यहाँ पर काट दिया मैंने. So see how much I'm getting? Minus 183 into 16 divided by 10 is equals to F minus of 32. Option D, minus of 273. Yeah. Simplify kar lo, we'll be getting the answer. F is equals to minus of 297 degree Fahrenheit. Done, beta? So next one. Two thermometers X and Y have the ice points marked at 15 degrees and 25 degrees and steam points marked at 75 degrees and 125 degrees respectively. When thermometer X measures the temperature of the bath as 60 degrees centigrade on it, what would be thermometer Y read when it is used to measure the temperature of the same bath? So direct question here. Can anyone tell me the answer for this one? Formula I told you. Reading point minus of your ice point divided by vapor point minus of your ice point is equals to constant. ठीक है, steam point भी लिख सकते हो, उसमें कोई problem नहीं है. So first one, what is the reading beta? We have got two thermometers X and Y. This is one thermometer and this is your another thermometer. This is your X and this is your Y. As an ice point marked as for this ice point is 15 degrees centigrade and for this ice point is 25 degrees centigrade. And steam points are marked as 75 and this one it is 125. When the thermometer X reads a temperature bath as 60, that means here the reading is somewhere around for me 60 on it. What would be the thermometer Y read when it is used to measure the temperature of the same bath? So here what will be the reading? So this reading is equals to how much? Can anyone tell me? So first reading is your 60 minus ice point is nothing but of your 15 divided by your 75 minus of your 15 is equals to, for other one I don't know, it is your X minus freezing point is nothing but of your ice point is 25 divided by 125 minus of 25. So 60 minus 15 is how much better? 45 divided by your 50 is equals to your X minus 25 divided by your 100. This 0 will get cancelled. So this will be 5 ones are 5 twos are 10. So that will be equal to your 45 into your 2 is equals to X minus of 25. How much better this one? 45 twos are how much? 45 twos are 90 degrees it is coming. Doesn't here
115, sir.
115 is equals to X minus 25.
So
X will be
90. 90 is equal to X minus 25.
Sorry, कुछ काम पे आ गया था. How much I'm getting X value beta? X value is equals to कितना आ रहा? What I'm getting the answer beta? 115. 115 is not there, so I can nearby write the answer as 100 degrees centigrade.
Okay, sir.
What I'm checking, isn't it? So this will be equal to your 90 is equals to X minus 25. X will be your 90 plus of your 25. That will be equal to your how much for me? 115. So nearby only option which I can tick is nothing but 100. ठीक है ना? Is that clear? Chalo. Next one. The reading of a bath on the Celsius and the Fahrenheit thermometers are in the ratio 2:5. The temperature of the bath will be equal to how much? Chalo, try to do this one beta. The reading of your bath on the Celsius scale and the Fahrenheit thermometers are in the ratio of your 2:5. The temperature of the bath will be equal to how much? Reading on Celsius and Fahrenheit. That means C by F. C by F is given as of your 2 by F. 2/5. The temperature on this bath will be equal to how much? Answers are in the degree centigrade is given for. C is equals to 5/9 into your F minus of your 32. I can use this formula. C value is equal to how much beta? So I can write here C is equals to 2 by 5 times of your F. So it is 2 by 5 times of your F is equals to your 5 by 9 into your F minus of your 32. Done. So 2 by 5 is how much beta? 0.4 into your F into your 9 is equals to 5F minus of your 160. So F value will become how much for me beta? How much I'm getting this one? 0.4 into your F into 9 is equals to 5. All the F terms you take on one side. See how much I'm getting? कितना आ रहा है बेटा? C of here. Okay. आ गया सभी को? This is how much better? 0.36 times of your F is equals to 5F minus of your 160. Okay. So minus it is there, it will go here, it will become for me plus. All the F terms you can take on one side better, isn't it? So yeah, F value will become for me 45.71 degrees centigrade. This one is in your foreign heat better, sorry, that we need in the Celsius, no? I'm getting the foreign heat value is equals to how much? F value is how much I'm getting? 114.28 degree foreign heat.
So first option.
How first option beta? Minus 26 ara. This one is 114.28 degree foreign heat I got. You convert that one into Celsius.
Sir, what I did is I took this minus 160 on the left side and the and this 0.36 on the right side. So
no, तो क्या हो जाएगा?
4.64 F is equal to 160. So F is equal to 160 by 4. Oh, sorry. Yes, sir. 160 by 4.64. ऑप्शंस में नहीं है सर, आंसर आया सो.
मम्मा 45 कुछ आ रहा है बेटा. See 2 by 5 value is how much for me? 0.4 into 114.28. This will come out for me 45.6 something. So 45.14.
सर टेम्परेचर ऑफ बाथ पूछ रहा है, यानी दोनों का पूछ रहा क्या सर?
No, no, no. The reading of the bath on the Celsius, यानी कुछ water का temperature on Celsius and Fahrenheit thermometer 2:5 में दे रखा है. So he's asking the temperature of this total bath only, either in the Celsius or either in the Fahrenheit. We got the answer in the Fahrenheit as of your 114.28 degree Fahrenheit. But options are given in degree centigrade. That is the reason I'm converting this Fahrenheit in this formula again. So substituting that value, I'm getting the value of the C is 45.6. Clear? Chalo. Next question, beta. Try kariye. The volume of the metal sphere increases by 0.15% when its temperature is raised by 24 degrees centigrade. The coefficient of linear expansion of the metal is equals to how much? The volume of the metal sphere is increased by 0.15% when its temperature is raised by 24 degrees centigrade. The coefficient of linear expansion of the metal is equal to how much? Change in volume is given as 0.15%. Okay, so change in volume is equal to how much? But if I'm converting into this one, 0.15 divided by over 100. That means that will become for me 0. This will become for me 0. This is 0.0. This will become for me 15. The volume of a metal sphere increases by 0.15% when its temperature is increased by over 24 degrees centigrade. That means delta T is given as 24 degrees centigrade. It is asking the coefficient of your linear expansion. That means alpha is equal to how much? We know the formula, change in volume is equals to original volume into your gamma into your delta T. Delta V is equal to how much better? 0.1% of your V. So this is also your V. That means this will become for me 0.0015 into V is equals to V into gamma into temperature difference is 24 degrees centigrade. Okay. So this V and this V also gets cancelled here. So that will be equal to your how much? Gamma value I'll be getting. Gamma is equal to how much for me? 3 times of your alpha. Isn't it? That means this will become for me 0.0015 is equals to 3 times of your alpha into your 24. So I can write from this one, alpha is equals to how much for me? Alpha is equals to 0.0015 divided by your 3 into your 24.
Times gamma.
Yes, beta.
Gamma is equal to 3 alpha. Yes, I got it, sir.
Yesterday I told you, no, alpha is to, beta is to, gamma is equals to 1 is to, 2 is to 3.
Yes, sir.
So gamma is equals to 3 times of alpha. So in the place of gamma, I'm writing 3 alpha. Alpha is 0.015 divided by 3 into 24. See how much I'm getting?
So fourth option, sir?
Fourth option, Ara.
Yes, sir.
So this one is how much better? I can write this one as 0.625 into 10 to the power of your how much? 1, 2, 3, 4 na? Because a calculation dekh lo beta. This is coming out for me 0.000625 divided by 3. So this can be taken as of your 6.25 into 10 to the power of how much beta? -5 divided by 3. Okay. So this one is a 3 1s are 3 2s are 6. Isn't it? So approximately 2 bole to 2.5. 2.0, not 2.5 in jata. So it is 2. Second option I can write. 10 to the power of -5. Aya?
Yes, sir. Yes, sir.
Chalo. Option B. Chalo. Next one. Suppose there is a hole in a copper plate. On heating the plate, the diameter of the hole would be always increase, always decrease, always remains the same, none of this. कल first point यही लिखा है मैंने. What is the first point I have written, beta?
Increase, sir.
Always increases. Anything in this one always increases. A must be the answer for this. Sure. Next one. हो गया क्या? Yeah. If two rods of length L and 2L having the coefficient of linear expansion alpha into alpha are connected so that the total length becomes 3L, the average coefficient of linear expansion of the composite rod will be equal to your how much? If you got a two rods of length L and 2L beta, this is your one rod of length L and another rod of length 2L of coefficient of linear expansion alpha, and this one is a 2 alpha are connected. Both of them are connected. So that the total length becomes 3L. Okay, now this is your total length. This is your total length. This is your 3L. So average of this one will be equal to how much for the composite rod? How much beta? Anyone? The average coefficient of linear expansion of the composite rod is asking. See, when you're adding this one, the change in the length in this one, how do you write beta? Delta L is equals to alpha into your L into your delta T, isn't it? For the first one. In the same way, delta L2 for the second rod, this will be equal to 2 alpha into length is for this one 2L into your delta theta by same temperature. And alpha of composite will be equal to how much? Delta L of your composite will be equal to, this will become for me alpha of your average into effective length will become for me 3L into temperature will be your alpha. So therefore I can write here delta L of your composite will be equal to delta L in the expansion in the first rod plus delta L expansion in the second rod. Yani alpha of your average into your 3L into your delta T will be equal to your alpha into L into delta T plus this one is 2 alpha into your 2L into your delta T. Anything is getting cancelled in this one you see right now. So this delta T and this delta T will get cancelled. So if I simplify this one, alpha average will be equal to your alpha average into your 3L will be equal to your alpha of your L plus of your 2 into 2, 4 alpha into your L. That means this will become for me 5 alpha into your L. So this is your alpha average into 3L. This L will get cancelled. So alpha average of the composite rod will become for me 5 alpha divided by 3. Okay. So this will become for me 5 alpha divided by your 3. This will be the answer. 5 alpha divided by 3. Third option. Clear beta? Sir C. Very good. Chalo. Next one. Temperature is a measure of hotness or coldness, heat possessed by a body, potential energy, thermal energy.
A sir, hotness or coldness.
Hotness or coldness. ठीक है?
Yes.
So this was some of the basic questions beta. You should have been done. Now I'll try to take you to the other slide where we can do the concepts very fastly. Just a minute. ध्यान दे रहा हूँ क्या की पे Sure. See this one better. Applications of the thermal expansion of your solids. Platinum is used to seal the glass. Platinum is used to seal the glass. Why? Alpha of your platinum is equals to alpha of your glass. Coefficient of linear expansion of your platinum is almost all equal to the coefficient of linear expansion of the glass. So to seal the glass or for repairing of a glass, we use the platinum. This one is really very important. See it. A thin rod and a thick rod of the same length and made up of the same material are heated through the same temperature difference. This word is very important here. Are being heated by the same temperature difference, which expands more. Like say this is a thin rod of length L, alpha, temperature difference delta T. This is your thick rod, length is same L, same material alpha, temperature difference is delta T. So temperature, they are been heated through, they are being heated. This one is your heated through the same temperature difference. That means expansion in this one is same. Expansion formula is how much better? Delta L is equal to L into alpha into your delta T. Okay. See here. So I'm writing here L into alpha into delta T is equal to L into alpha into delta T. Delta T and delta T are same. So I can say that expansion in the thicker rod will be equal to your expansion in the thin rod. That means expansion is same in both the rods. It is independent of your masses of the body. If I take the sphere also better, expansion in volume will be the same, provided if they are heated through the same temperature difference. Thin, thick, generally students will think that lesser mass, so there will be more expansion in this one compared to the larger mass. No, as they have been heated through the same temperature difference, expansion is same, isn't it? Is it clear for this one? Nandini, point clear in the Marika?
Yes, sir.
Chalo. Next point you think right now easily and try to give me the answer. Very, very important. Again, same concept. We got a thin rod and a thick rod. We are made up of the same material and of same length. Better. Thin rod and thick rod made up of the same material and same length are heated by the same amount of the heat. Then which rod will expand more is asking. Which rod will expand by the same. Now we are given for me what better? Same amount of heat, not temperature difference. That means delta Q. So this is your thin rod. This is your thick rod. Expansion formula same again, delta L is equal to L into alpha into delta T. Okay, so expansion is directly proportional to your temperature difference. Now, as it is given the same amount of heat, we know the heat formula better. Q is equal to ms into delta theta. Delta T is temperature difference, S is your specific heat, M is mass, Q is heat. In the problem is telling that same amount of heat, delta Q. So Q is same. That means temperature difference is equal to your Q by M into your S. Q is same, specific heat is same, so temperature difference is inversely proportional to mass. So increase in the length is inversely proportional to mass. So lesser the mass, more will be the expansion. So lesser mass expands more. So thin rod expands more on your heating at the same amount of heat. Is this 2 points clear for everyone? First one was at the same amount of temperature difference. Now this one is at the same amount of heat. Any doubt in this one? So thin rod will expand more on your heating. Example, even in this one right now, if I'm taking hollow sphere and solid sphere are heated by the same amount of delta Q. That means same heat. Then hollow sphere expands more compared to the other one because mass of that one is less compared to the solid sphere. Clear, beta? Chalo. Next one, expansion of the composite rods, beta, series combination. If I'm taking the two rods, beta, this one is the first rod of length L1, second rod of length L2, made up of coefficient of linear expansion alpha 1, this one is alpha 2. Temperature difference are same. That means if they are being added at the same temperature difference, alpha equivalent in series is equals to summation of L into alpha divided by summation of L. Like say like two rods are being given, alpha equivalent of series will be equal to L1 alpha 1 plus L2 alpha 2 divided by L1 plus L2. So proof is not required for that one. Directly remember the answer for that one. That's more than enough. In the parallel combination beta, when two rods are being connected in the parallel beta, this is your L1, this is your L2, alpha 1 and alpha 2, and temperature difference is delta T. Then alpha equivalent in parallel will be equal to summation of alpha by L divided by summation of 1 by L. For two rods, if I'm taking alpha 1 by L1 plus alpha 2 by L2 divided by 1 by L1 plus 1 by L2. Okay. So yesterday already I told you thermal stress. You can just go through it. This formula also, you can derive this relationship here. A rod of linear coefficient alpha is been heated through a temperature difference delta T. Then moment of inertia increases. Then fractional increase in its moment of inertia is how much? We got a rod of linear coefficient alpha beta. This is your rod. Coefficient of linear expansion is alpha. Length is L1. Temperature is delta T. Is heated through a temperature difference of your delta T. Now it has been heated to a temperature difference of delta T. Then its moment of inertia increases. Then fractional increase in its moment of inertia is asking. Now for the rod, moment of inertia generally will be equal to mass into your r square. Mass is constant, so moment of inertia is directly proportional to the square of your distance. So delta I by I is equals to 2 into delta r by r. I'm using the error approximation. So that is equals to 2 times of delta L by L. We know the formula alpha is equals to delta L by L into delta T. So delta L by L will be equal to alpha into delta T. So it is 2 into alpha into delta T. So moment of inertia, change in moment of inertia divided by original moment of inertia is 2 times of alpha into your delta T. 2 times of your alpha into your delta T. Clear, beta? So see here, if I am writing this value right now here, so delta I will be equal to your 2 alpha into I1 into delta T. I2 minus I1 is equals to 2 alpha into I1 into delta T. Minus if it goes here, this will become for me I1 plus 2 times of alpha I1 into delta T. I1 will become common, so I2 will be equal to I1 into 1 plus 2 alpha into delta T. So I2 by I1 will be equal to how much, beta? 1 plus 2 alpha into delta T. Very, very, very important formula, beta. Okay. The same way, when the rod is rotating, the net torque acting on that one will be 0. Net force will also be 0. So angular momentum is conserved. Initial angular momentum must be equal to final angular momentum. So I1 omega 1 is equal to I2 omega 2. So omega 1 by omega 2 is I2 by I1. So this I2 by I1 I am writing here, it is 1 plus 2 alpha into delta T. So omega 2 by omega 1 will be equal to 1 plus 2 alpha into delta T. Our angular velocity omega 2 will be equal to your omega 1 divided by 1 plus of your 2 alpha into your delta T. These are 2-3 important formulas you need to remember. I'll send you these notes. Don't bother about the material of this one. Yeah, this problem is also you see. If the length of this cylinder on heating increases by 2%, the area of its base will increase by how much? Delta L formula, L naught alpha into delta T. So delta L by L naught is alpha into delta T. Delta L by L is given how much for me? 2%. So 2% is equals to alpha into delta T. That means 2 by 100 is alpha into delta T. In area, if I am writing, change in area is equals to A naught beta into delta T. So delta A by A naught is beta into delta T. So delta A by A naught is equals to beta will be equal to 2 times of alpha. So 2 into alpha into delta T. Alpha into delta T value is 2 by 100. So delta A by A naught is equals to 2 into 2 by 100. It is 4 by 100. That will become for me 4%. Clear? Sure. Next one. This question. A metallic solid sphere is rotating about its diameter as the axis of rotation. If the temperature is increased by 200 degrees centigrade, the percentage increase in its moment of inertia is how much? Alpha of metal is given. For solid sphere, moment of inertia is 2 by 5 mr square. For hollow sphere, it is 2 by 3 mr square. Delta I by I is equal to how much better? 2 times of delta L by L, or delta I di by I into 100 is equal to 2 alpha into delta T into 100. So it is 2 into alpha value is 10 to the power of minus 5. Delta T is 200 into 100. So simplify it, we'll be getting the answer for this one as 0.4%. Next one, yesterday I already told you this one, variation of a density. Action of barometer is not required. Metallic tapes, beta, very important. Now see this one, beta. Metallic tapes. The temperature at which the tapes gives the correct measurement is called as of your calibrated temperature, beta. The temperature at which the tape gives the correct measurement is called as what? Calibrated temperature. Let the calibrated temperature of the tape or scale will be equal to how much better? T1 degree centigrade. So if the tape is used at T2 degree centigrade, what happens? Listen once again. We are manufacturing the metal tapes better. The temperature at which the tapes gives you correct measurement, we call it as of your calibrated temperature. Like say I am the manufacturer of your some tapes. I'm manufacturing the tapes at T1 degree centigrade. Like say I'm having a company in India. I'm manufacturing the scales which I can import to other countries like say Dubai, Canada, anywhere basically higher temperature, lower temperatures. But in India at normal temperature at T1 degree centigrade, I have been calibrated the temperature of the scale as T1 and I manufactured all the scales at that one. Now if the tape is used at T2 degree centigrade, like say if I manufacture at 10 degrees centigrade and you're using it at 20 degrees centigrade, some other fellow is using it minus 20 degrees centigrade, obviously the reading what he will be getting will be different together. Isn't it? So you'll be getting the different readings for that one. So in order to overcome that one, how do you do the problems related to the metal plate? Now see first one. This is the specimen beta. The specimen means the material which we are using to measure the scale. Like say I brought some material, like some specimen have been brought it, I'm measuring it. So let's say a T1 calibrated temperature, true length will be equal to measured length. Like say I'm measuring the temperature in India itself at a temperature T1, then true length will be equal to measured length. So true length will be equal to L of your measured length. Now see, this one is something very important right now. Scale is used at T2. T2 greater than T1. That means if the scale is being exported to Dubai, where the temperature is more. So length, you know that metal will be expanding on when increases the temperature. So now when you are measuring the same specimen in the Dubai, the meter scale is increasing. So when the meter scale is increasing, the reading shown by this one will be equal to how much? Measured value will be lesser than of your true value. Isn't it? Because right now they expanded, Gada. Isn't it? When it is being expanded right now, the reading will go in the front direction and it will be showing for me lesser value. So measured value, whatever you are measuring value, that will be lesser than of your true value. That means measured value will be equal to lesser than true value. So correction must be equal to how much for me? This much of correction. Delta L you must add it. So true length will be equal to measured length, this measured length plus this delta L you should add. So true length will be equal to delta M plus LM into alpha into delta L. Now if I'm using the scale at your T2 degrees centigrade, like cold countries like Canada, isn't it? So what happened in the colder countries, the scale will contract. The scale will contract right now. So when the scale is been contracting, the reading shown by the specimen will be right now more. So measured value will be right now, this is your LM. This measured value will be greater than of your true value. So measured value is greater than true value. So that measured value is, this is error right now. So delta L is L into alpha into delta T. It should be subtracted. So true length will be equal to measured length minus of your delta L. So that will give me the answer for it. Clear? See. Pressure thermometer PT minus P naught divided by P naught into delta T into 100. How I got this one, beta? I told you that formula, X minus of your ice point divided by your steam point minus of your ice point will be into your 100 is equals to your constant. Okay. Our volume thermometer Vt minus V naught divided by volume at 100 degrees centigrade minus volume at 0 degrees centigrade into 100. Resistance thermometer RT minus R naught divided by resistance at 100 degrees centigrade minus resistance at 0 degrees centigrade into 100 part of this. Clear? So these are some problems there right now. You can do it. See this one. Resistance at 25 degrees centigrade is given as 50 ohm and at 100 degrees centigrade is given as 80 ohms. Find the resistance at 60 degrees is asked. So 80 minus 50 divided by 100 minus 25 is equals to R minus 50 divided by 60 minus 25. Simplify it, we'll get the resistance to be equal to 64 ohms. Done, beta. So tomorrow we'll start with your expansion of your liquids. I'll tell you on this one only, so it will be more better. So it is already derived conditions. These all lectures are already uploaded on my channel, but recently only I have taught it. You can just do it out within 1 week back, 2 weeks back. So only these all lectures are there already. Okay, beta? Sure. Bye, beta.